and circuit. About this, we will discuss uh, regarding this at level of 6 and 7. Clear? As much as possible from our side, it will be discussed by us. We will discuss with the details. Okay. Did you know what? Did you know before this discussion, before this lecture, uh, physics, 80% of physics is a what is mathematics. 20% of physics is a language without physics. You can say. So here I want to say you that if we are discussing in the context of this physics subject, we have taken this is subject in intermediate level in graduation level. Then sure we make sure we should make sure that numericals in physics would be very compulsory. Okay, numericals which means mathematics. So 80% of mathematics will be discussed in our physics context. Okay, as possible. 20%. I think so. 20% language of physics is enough. Uh, but otherwise we can expand it at 30%. But numericals in physics is very compulsory. Numericals, okay. So numericals we will add with our physics language. Electricity. Electricity. What would you like to say regarding electricity? What do you think about it word, about the circuit, about electricity? Somebody would ask you, if somebody asks you, then what would be your perspective? What would you be your perspective regarding this? Quickly, immediately, in your mind would come regarding this. You would say, electricity. We use electricity in our house, and a lot of place, a lot of place, in a lot of place. This is used. This is used, and to glow up a bulb, we use electricity for machine. And in machine, if we see, then there are a lot of machine. Okay, there are a lot of machine. So machine which would be need electricity. Without electricity, machine would not work. Machine is used as a what to provide water. In agriculture, what is used to what irrigation. For irrigation in agriculture land, we use a named machine. Okay, so also electric machine will not will be incomplete without electricity. Okay, so in devices, in electric devices, in a machine, electric machine, electricity is being used. Electricity is used to glow up a bulb in a wedding, wedding, wedding. Okay, in wedding we see what uses of bulbs, uses of bulbs. Okay, so we can see what in a night bulbs, machines, fans use to use bulb to use machine is used by the help of electricity. Okay, by the help of electricity. So electricity is a part to connect with the electricity device. Okay, it provides to electric device what current, electric. Okay, We will delve it in detail. Just you see, circuit. Circuit is a path, and here an electric circuit we will discuss. So here electricity, it gives us current electricity to use in something devices, in something electric devices. If we wanted to glow up a bulb, then we will use this. Okay. So regarding this, about this, when we will complete of this, then our perspective on it will be clear. Electric cell. Electric cell. This is electrician. I hope you might have seen electric cell in your childhood. This electric cell is used as is used in watch, in wall watch, in wall watch. Okay. So here we are going to discuss about electric cell. We will understand the functions of this electric cell. We will understand the parts of this cell. This is part that is said what is metal cap, because it is a cap and it is made up by what metal. That's why it is said what metal cap. This is a disc cap. No, this is flat. So it is said what flat. So it is made by metal. So here we can say disc metal. Okay. Otherwise, you can say flat. Flat, which means what? Like this, flat. This is a shape. Flat is a shape. Okay. So it is the shape of a flat. It is the shape of a cap. That's why it is a shape metal cap. Clear? So this metal cap is the indication of a positive terminal. Of a positive terminal. Of a positive terminal. Clear? So here metal cap, you will help to identify terminal of a positive. So here we see what a printed plus sign. Here you will see. Similar, each electric cell has two terminal. First positive and second negative. Clear? So end of electric cell, one side of end of electric cell will be what positive terminal, and other end side of electric cell will be seen what a printed subtract sign that explains a negative terminal. So this side is what negative. This disc metal helps us to identify negative terminal. Negative terminal. Clear. So this cap is a negative terminal, and this is a hint of negative terminal. This add is a hint of a positive terminal, and this metal cap is an indication of positive terminal. Clear. So inside it is found what a chemical stored. Chemical stored. Inside electric cell is found chemical stored. This is what which provides which provides a current with to another devices. Clear? This is a bulb. And here this electric with this help of positive terminal wire will go through wire inside it, and then second negative terminal wire from here will go till here, and both wire are providing what this chemical storage, that is current, that is electric. So this chemical storage is going through this wire inside. This will pass through this electric bulb, and then it will come out through help of negative terminal, like this. Clear about electric bulb? We will understand in other discussion. So this is chemical storage which provides electricity, which provides current. So work of electricity, work of chemical storage is to provide current, is to provide what electricity. So positive terminal, with the positive terminal, wire is a connector, and this positive terminal wire will connect with positive terminal of electric bulb. This is just example, and then other side, this negative terminal wire will be connected with the negative terminal wire of electric bulb. Then it will work out. Clear? Then bulb will work. Then bulb will glow up. I think that was all. That was all. So here, when it comes to the point of battery, then here we can see differences between battery. It is just a electricity. That's why this electricity has a less capacity as compared to if we see the battery capacity of battery, because battery is a collection of electric cells, so it has more cells. That's why of course battery will have more capacity, and it has less capacity. That's why it is used in a normal devices, in a small devices, whereas battery is made up for advanced devices, so it will be used in advanced electric devices. So work of this electric cell is used in normal devices, as you know. One side, let's understand about battery. Like this, you might have seen. I think diagram of electric cell, diagram of battery is not perfect, but just to understand. Okay, just to understand. This is battery. So inside it, as we know already, as we discussed here, each electric device which provides current electricity has two terminals. One is positive, which indicate is what, and second is what, negative. It is said what, negative terminal, and here negative terminal wire will be connected with this negative terminal, and here positive wire will be connected with the positive terminal. So these were the terminals of this battery, and now you are looking this widely and lengthily. What inside it is found what, chemical storage. As we discussed about chemical storage inside electric cell, also Inside the battery, inside the battery is found what chemical storage. Chemical storage. This part is of chemical storage. It will provide chemical through help of these two terminals. Clear? And you can see here, here, this space is more to keep chemical storage, and here a space to keep chemical storage is less as compared to a space of a battery. That's why it has a less capacity, less it has a less power. It has a more power because it has a more chemical storage. Okay, more chemical storage, more chemical storage. We already know if we say if we wanted to say what how many electric cell would be calculated inside it. How many would be electric cells? How many would electric cells would be inside it? So here we can say mm, more than two, more than two. So that's why we say what it is a collection of electric cell. It is a group of electric cells. Clear? About terminals we understood, and about chemical storage we understood, and it is a one electric cell. It is a group of uh, yeah. I think that also. Let's understand about bulb. Okay, about bulb. About the bulb. Try to focus here. Bulb. This is a diagram of bulb. I know it is not a perfect diagram of bulb, but just to understand, it is enough. Okay. This is a what to connect wire like this. So with the discussion of a bulb, we will also try to understand about a filament, because filament is found inside bulb. Okay, inside bulb. So this side area of bulb is made up of glass, chemical glass. Inside bulb, bulb is what gas. I don't know name of that gas. But here you are looking curved wire. It is a wire. It is a what wire? So it is a curved wire. It is not a straight wire. This is a straight and this is wire. So it is a straight wire. So this is not a straight wire. That's why we are not saying this is what straight wire. This is what curved. Curved, which means straight. Clear? So this curved wire, it curved wire is known as what? Filament. Filament. So name of this curved wire is filament. Clear? Name of this curved wire is what? Filament. That's it for now. Now this filament will glow up as a light. Clear? Electricity through this filament wire will pass. Okay, will pass. Electricity will pass through this filament wire. And sometimes we listen fuse bulb. What? Fuse bulb. fusible. So when will we say this is a bulb fusible, this is not fusible? When would we say? We will come on this discussion. Don't worry. Don't worry. So fuse bulb. So this filament wire, naked wire, will decide when will bulb be fused and when will bulb not be fused. This filament will decide. Clear? This is a filament. If this filament is broken, if this filament is found broken, then this bulb will not glow up because filament is broken. And in other side, in other word, we say it is a what? Uh, let's suppose like this, like this. This is a broken filament. That's why it is said what? Fuse bulb. It is said what? Fuse bulb. When we see uh, broken filament, then but filament is a well, then absolutely it will glow up because it is a well. Okay, but filament will be found as a broken wire, then it will be known as fusible. But filament is well, so it means this will glow up. The bulb will glow up. Clear? Bulb will glow up. I think that's it. Yeah, that's it. Let's come on the topic of an electrical circuit. And this is a compulsory. With this discussion, we can understand about an electric circuit. Circuit which means a road, a path. So here in the context of electricity, we are going to talk about a circuit. So like this circuit maybe could be sometimes like this circuit could be made sometimes because circuit uh, most circuit regarding electricity is used is made in house in big building we can see a circuit of electricity in this electric circuit we can see what a bulb connection of a bulb connection of a fan connection of electric devices so all this determines what this is electrical device clear so as a discussion let's try to understand about an electrical circuit. So here this is wire. I hope we know. This is wire. Clear? This is a positive terminal wire. It is connected with a electrical device. Got it? Got it? Got it? And then this is wire. Keep this in your mind. And here this is electric switch. Electric switch. This is wire, and this wire is negative terminal. Clear? This is a negative terminal. This is a positive terminal. This is positive terminal. Got it? Just to remember it. Clear? So wire is connected. Wire is connected. That's why we are looking at one wire. Like we are looking one wire. So it is connected. So this wire is of negative terminal and this wire is of positive terminal. Got it? Positive terminal. And this is electric cell. Electric battery you can say. Electric battery. This is electric switch. This is electric switch. Got it? So also we need to understand about electric switch. So electric switch, importance of electric switch also we will understand through this electric circuit. So it is a bulb. It is what electric battery. This is wire. This is wire. This is electric switch. Clear? So it is what a requirement. These are requirements to make an electric circuit. These are requirements. So requirements are what electric bulb, electric battery, electric switch, wires. So these are requirements, and these requirements are few just to understand. But if we see this electric circuit in our house, then requirements would be more. Requirements will be more because we use electricity more. So we, already we know what these are requirements to make an electric circuit. Clear? So this is what circuit. This is a circuit. Clear? So circuit is a complete, and this is complete circuit is defining what it is working. It is working. Bulb will glow up because wire is well connected. Here is what electric battery and switch is in on mode and wire is well connected. Filament is well. That's why it is working. Bulb is glowing up. Bulb is glowing up because it is a well. Circuit is a well. Circuit is a complete. That's why. If we see one second about wire, let's understand about wire. So here you are looking what different. This is a named wire. Here end both end of wire we get we get removed. We get removed both end of this wire. So for some space we will get remove. We will remove this end of this electric wire. Okay, to connect with electric battery and with electric bulb. Clear? Clear. So we see what wire is made up of plastic. Wire is made up of plastic. So it is made up by plastic because of safety. We if we touch net wire and net wire is with flowing with electricity, then we can we can get contact with flowing electricity, then our life, we can lose our life by touching naked wire. So our safety, it is a made. It is made. This is made. Clear? For our safety, wire is made up by electricity. What? Plastic. Clear? Here we removed, we got removed end of this electric wire to connect with this electric bulb and with electric battery. Clear? And as we know, this metal cap is a hint of positive turn. So this is what positive turn, and this is a negative turn. This is what negative turn. This is negative turn. Clear? About wire we understood. About filament, about the bulb we already know. So it is a what circuit. These are requirements to make an electric circuit. Clear? Clear? If this we see what a gap between wire, broken wire. If we see what broken wire, if we see broken wire in a circuit of electricity, then it is what it will be known as uncompleted electricity circuit of electricity. It will be known as uncompleted because the wire is broken. Wire is broken. Okay. Now it will be known as uncompleted circuit. But wire is well connected, but filament is not well. Filament of bulb is not well. Then it will be, you can say, this will not work out. Also, you can say what it is incomplete because filament is broken, and we can say fuse bulb is fused. Clear? So, like this, we can decide when will an electric circuit be incomplete or complete circuit. Clear? What else do we need to understand? What else? Electrics on discussion of electricity. Let's come. Uh, say, buddy, it is used to turn off, to turn on. Okay, it is in mode off, which means wire is not connected with the other wire. It is a hint of, it is a hint that which is in mode off, but it is well connected. It is well connected. It is connected with the other wire. So it is deciding that now this electric switch is in mode on. Okay, mode on. Mode on. So it is made for us safety without any barrier, without getting shock with uh, flowing electricity. We can take help of this electric switch to turn off the bulb, to turn off the fan. Okay, we take help of this electric switch. When when we want to switch off, then it will be unconnected with another wire. Clear? Here one point is to notice what I think electricity is we understood. Now electric conductors, insulators. Why was made up of what? Uh, mm, why of plastic? Of plastic. This electric switch is made up of plastic. Okay. So plastic is what? Insulator. Insulator, which explains that those materials who cannot get attached with flowing electricity. So those materials will be known as electric insulators. So these are electric insulators. This plastic wood, wood window, wood door, book cannot get attached with the flowing electricity. That's why it is named electric insulators. That's why we are not able to connect with what flowing electricity because of insulators. Other side inside wire is what uh, electric conductors. Conductors are those materials which can get attached with us because these are good conductor for electricity. Insulators are bad conductor for current. Are you ready? So both are used to make an electric circuit. Both are used. Also, we see what use of electric conductors when bulb is made up. Also, we saw what uses of insulators when wire is made up. Inside wire is what electric conductors. If when we touch this net wire, which is what copper, could be silver. So silver is too expensive. That's why silver uses of silver we see minimum time because silver is too expensive than what copper. Clear? So also we can say use of plastic when electric switch is made. So electric switch helps us to prevent from flowing current. Clear? Electric conductor about insulators we understood. And with this practical example, we also understood what the definition of each this word. This word. This word. Heating effect of electric current. Can you tell me when we see when do we see heating effect of electric current? Also, we can see this. We can understand this by making uh, an electric circuit. Okay. So, can you explain it? Can you explain it? Electric components. We already know electric components by making an electric circuit. Just to revise, I will tell you again. So now heating effect. Heating means heat. Okay, heat. That is which is a form of energy. So this will hit by temperature. By temperature. So when can we see heating effect of electric current? When will it be possible? When will it be possible to see heating effect? I am giving to you little time to understand it, to explain it. Do you know? Here, we were understanding, we were looking what wire, this wire, this is a net area of a wire. This is why it is made by plastic. It is made up by plastic. So here we can see what heating effect of electric current with the help of this wire. This is connected with the electric battery device with the electric bulb. Let's suppose. Now I told you at least till here. Forward it. Can you tell me what will happen? What will happen? Look. Here is what heating effect of electric current. I am saying again and again heating effect because it is a compulsory. It would be compulsory. In upcoming our study of physics, it will be seen more time. So this is the net area of this wire. It is connected with what with the bulb. Let's suppose. Got it? Got it? This is a what electric cell. Now, if wire is too much, if wire is too much small, then it will hit soon. Then it will hit, it will burn soon. Soon, it will this bulb, this wire will get hit very soon because wire is too much small. So wire will decide, material will decide, material will decide. Why like this am I saying? Because uh, this is a bulb which we see in our room. If this bulb is that is used in a building in our house, and with this bulb we are using what electric cell, that was electric cell. Absolutely, it will not it will not work out because we are using electric cell. Electric cell is not sufficient for electric bulb. So to blow up electric bulb, we will have to use what our electricity, our current, which comes through what transformer. Okay, so those electricity will help to blow up a electric bulb. Not a electric cell will help to blow up bulb. Clear? So only okay. Yeah, this is a transformer. Got it? This is a transformer. This is a transformer. Electricity is going from through this. Electricity is going through this transformer. Uh, from this transformer and going. So here, why is too much small? Absolutely, of course, this will get hit very soon because we are using wire too much small as well as what wire is thin. Wire is a thin. You would see, might have seen, you must have seen what a thick wire is used uh, from a transformer to our house. Thick wire because our electricity, power of electricity is more. Okay, that's why thick wire is used to come current from transformer to our house. And work of a transformer is to convert into what low voltage, low current, so that everyone can take advantage of this electric current, electric current. Clear? So here we see what this wire is thin, this wire is too much small. Then absolutely this will get hit very soon. So here we need what thick wire and more what more lengthy wire. Okay. So heating effect of electric current will decide materials. If materials are not able to get attached for this work, then uh, this will not work. This will be said to be what fused. Uh, this will get hit very soon. So all material, all those material will decide. Heating effect of electric current we understood. Got it. Now, as we know, electric follows. Electricity is a follow of electric charge, typically through a conductor like a wire. Electric current, the rate of a follow of electric charge, measured in amperes. Example: when you switch on a light, for mathematically, I is represented to now electric current. Whenever we will see in the context of electric circuit, electric current, then it will hint about electric current. Got it? And ampere. Do you know what is ampere? Ampere. What is ampere? Ampere is to measure electric current. Ampere. Okay. To measure electric current. Uh, when we switch on light, then when we switch on light, then electricity follows through a wire, and electricity goes through this bulb to making glow. Already you know. So it is a compulsory for sometimes because it will help in mathematically. Potential difference: the work done to move a unit charge from one point to another, measured in volts. Example: a battery provides a potential difference that pushes electrons through a circuit. Types of electric current. Let's understand direct current, direct current, and alternating current. It is also DC. Do you know? Do you know about it? Alternating current. What is the definition of both of these from your perspective? Yeah. Here we are looking what word direct current. I have not written. I have not written definition of this. So direct, which means what? Current will go direct. Current will follow direct. This is the meaning of this word. Current will follow direct, which explains direct current. This is the sort of this word. So when does it happen? When does it happen? So battery. I am giving an example. An example: battery, cell, battery cell, and so on. More battery, more cell. These are examples of direct current because these electric devices electric devices provide direct current to another electric device. For example, toy, toy. So this electric device provides what? A current direct without any barrier, without any Ohm's law, without any resistance. Clear? So this is used in normal devices. This was a definition for normal devices. Now alternating current. Alternating current. Uh, Current follows without what? Without direct. It will come in different direction. Current will follow in different. Current will follow in a different direction. In different direction. And household bulb, household electric device, fan, for example, fan. This is example. Okay, this is example. So bulb we say fan. Uh, fan will rotate when electricity will follow through this fan. So electricity is coming from transformer and their transformer. Okay, and then electricity will follow in different direction. Some electricity will come in what will follow through what through electric fan, and some electricity will follow through electric bulb like this. So this is a direction of this is a direction to follow electricity. Clear? So it is that's why it is said what alternating current and short is AC. AC changes direction periodically. Household electricity. Clear? So it is more compulsory to understand because examples of it we will see more, and this will help to understand in mathematically electricity. So this is a bulb. Got it? This is bulb. This is wire. Here is a switch. This is a switch. This is a fan. This is a fan. Like this is a wire. This is a fan. Let's suppose this is bulb. This is bulb. Now, if this switch is in mode off, here electricity will not follow through this fan. But this is in mode on, so electricity will go will follow through this electric bulb. So here electricity is not going through this electric fan because of switch is in mode off. So it is what? Electricity, rather than going this side, is going this side. This is what, like this is happening because of it is saying this is alternating current. If your switch of a fan is in a mode of then it will not follow through the uh, through electric fan. But whereas this is in what this this is in mode one. So here that's it. This is a process to define alternating current. Clear? About transformer. About the transformer, we will don't worry about transformer. So direct current and alternating current. I hope we understood. So it was just what uh, definition and example uh, and helps us to understand meaning of word. Alternative, which means in a different direction, one work will be stopped, but second work can be what can be worked by us. It is seen in what high. It is seen where high electricity is flowing through electricity device. Do do you know some little bit information about Ohm's law? About Ohm's law. Let's see about Ohm's law. Ohm's law. About Ohm's law. What do you think regarding this? For now, as of now, we will understand. We will see what just a hint. So in mathematically, how is it written uh, to represent Ohm's law? In mathematics, V is equal to IR. So V, which means a voltage, current, voltage. You can say current, voltage of a current, and I, electricity, and R, resistance, which means Ohm's law. Ohm's law, resistance. So it is a compulsory to write. Yeah, because here we are looking what is just some hint of Ohm's law. It is a voltage. Voltage. This is a current. This is a resistance. This is a resistance. So it stops current. Okay, it stops current. Voltage. It will tell us how many are there voltage of a current. Clear? So which means voltage, I which means current, R which means resistance, which means resistance. So a resistance is a said what ohms law. So this was just what in mathematical form. So R is a resistance, which means ohms law. Clear? About current we saw before this discussion. Current which means electricity, current which means electricity. Voltage it will tell you as you know. Resistance will be barrier for flowing a current. So it will stop. I don't know when some numericals we say, then we will be clear completely. If if a resistor of a 2 ohms law has a current of 3 amperes flowing through it, the voltage across the resistor is V electrical power and energy. Electrical power and energy. So that was all regarding ohms. Clear? With with a numerical, we will use this formula. You can say. So we are moving to next. Next is electrical power and energy. Let's understand about power. The rate at which electric energy is consumed, produced, measured in watts. Electrical power and energy. Clear? First of all, power, let's understand. So, what would you like to say regarding electrical power? It is saying whatever is the rate, but at which electrical energy is being consumed, is being produced, is measured in watts. In watts. Clear? Uh, for example, a 60-watt light bulb uses a 60 joules of energy per second. The rate at which electric is being used, consumed. Clear? So it will be measured in volts. In short, W. So power, it is saying what energy is being used, energy is consumed. Uh, electric is consumed. For example, a glowing bulb is consumed. A glowing bulb is consumed. How many watts? 60 watt. 60 watt. A glowing bulb. A glowing bulb is consumed. How many? 60 watt. So it is saying what this bulb is consumed 60 watts. So can we say what is energy when bulb was consumed 60 watts, it consumed how many? 60 joules energy. Joules. Are you getting? Means it is consumed 60 watts. So it is saying what energy will be consumed how many? 60 watts by 60 joules by glowing up. By glowing up. Let's understand by an example. A bulb is 60-watt light bulb use 60 watt 60 watt. So here 60 joules. It is because it is saying what 60 watt light bulb used. So it is using what 60 joules per second. Joules of energy per second. Now try to understand this statement. It is saying what 60 watt light will use how many 60 joule. 60 watt light will consume 60 joule per second. Per second, okay. 1 second, 60 joule will consume. Whoa, 60 watt light bulb per second. If this is a 70 watt light bulb, then per second this will consume how many? 70 joule of energy. We will be more clear through practically. So it is just what reviewed of mathematically in electricity. So it is saying 60 watt bulb will consume 60 joules, but per mile, per second, which means time. How many joule will be consumed by 60 watt light bulb? How many? 60 joule. Clear? 60 joule. As much, we will understand this by mathematically, we will be more clear by practicing in mathematics. Let's understand now energy. Energy. So power which will be meaning what it would be consumed. It would be consumed. Clear? Now energy. At a discussion of energy, that's we already know energy consumed what? What energy is measured. It is measured in. It is measured in joule. In short, we say what J. So it is measured in joules. So it is what SI unit of energy. Joule is SI unit of energy. So SI unit of work will be what? Joule. Also kilowatt hour, or you can say kilowatt hour. Kilowatt hour. So that's why uh, work is also SI unit of joule is also SI unit of work. If a 100 watt bulb is used for 10 hours, the energy consumed is how many? 100 watt times 1 kilometer per watt per hour. I am writing. Okay. Through example, let's say clear. Let's make it clear. A bulb. This is example. If a 100 watt bulb is used for 10 hours, for 10 hours, the energy consumed is, this is weight 10. Weight 10. How many energy is consumed? How many is energy consumed? So bulb is of 100 watt and it is being used for 10 hours. For 10 hours. So 10 hours is our time. It will be represented by T. A bulb is of 100 watt. and we needed to find out what joule energy. Okay, energy. How many is energy consumed? How many? So 100 watt bulb and 100 hour. That is what T. 100 hour. Clear? Is it right? Is it right? Here we are right, but how will kilo come here? No, because we have a W and H. Here we multiplied. Here we multiplied. So here this is energy. Yeah, this is energy. 1000 WH. No, no, no. Per hour per watt. How many is energy being consumed? So here what 1000 3030 will cut, and now we have one. This is the equation. This is a way to find out how many is energy consumed. So 1 kilowatt per hour is being per hour is energy being consumed for 10 hours. For 10 hours. Clear? So here per hour how many? 1 kilowatt. So 10 times. So 10 times will be how many? 10 kilo. 10 10 till 10 hours. We see what how many will be, how many would energy be consumed? How many? 10 kilowatt. 10 kilowatt. 1000 watt. 1000 watt per hour was consumed. For as of now, that's all. That's all. I think so. We are entering in mathematics. It will be more better. Gradually, we will understand in mathematically field of physics.